So in this problem, we're being asked to write the equation for the line tangent to a particular implicit relation, which we have right here, 2x to the fourth minus 5xy squared equals 7y cubed. And we're told at what point we are trying to write the tangent line, at the point when x is -1 and y is +1. So remember, when we are asked to write the equation of a tangent line, that is pointing to the derivative, because the derivative gives us the slope of the tangent line. And to write the equation of a line, we need a y value, an x value, and the slope. So I've got an x value, I've got a y value, I need to find the slope, and the slope is the derivative of that original function. So we're going to use implicit differentiation to take the derivative now. I'll rewrite this down here where I have a little more space. And the nice thing about this is with implicit differentiation, I am able to take the derivative of each term as I get to it. So the derivative of 2x to the fourth would be 8x cubed. I bring the power down and go to 1 less power. Now, next step, I need to subtract the derivative of this, which hopefully you're noticing this is a product, so I will need to use the product rule. My u will be 5x, and my v will be y squared. The derivative of u will be 5, and the derivative of v will be 2y, bringing the power down and going to 1 less power. But since it's a function that we don't know, we need to multiply by the derivative of the inside, which is y prime. Now putting those back together, I will do 5 times y squared. And notice that since this was subtracting, I'm going to subtract both of these derivatives. So then I'll subtract 10xy, y prime. Now, I want to pause for a moment to notice I had a great question yesterday about whether the order of these matters. I go in alphabetical order, and I always put y prime last, and that's just a strategy I use so the y prime doesn't get lost and I have something consistent, but that isn't the way it has to be. That's the way that I choose to do it. I just recommend that you find a way that helps you to keep track of all of your terms. So I've taken the derivative of 5xy squared. So now I'm going to move to my last term. The derivative of 7y cubed will be 21y squared. So I bring the power down, go to 1 less power, times the derivative of the inside, which we'll call y prime. Now I need to isolate y prime. So I'm going to add the 10xy y prime to both sides, so that I can isolate that, and I'll be left with 8x cubed minus 5y squared on the left is equal to 21y squared y prime plus 10xy y prime. Now my point in doing that is to be able to factor out my y. So I'll take a y prime out front. I'll be left with 21y squared plus 10xy, and over here I'll have the 8x cubed minus 5y squared. Now I'll divide both sides by the 21y squared plus 10xy to get my final answer, which is my derivative, y prime, is equal to 8x cubed minus 5y squared over 21y squared plus 10xy. Now, if I were simply asking for the derivative, you would be done. But I'm asking you to write the equation of the line tangent to the implicit function we started with at a particular point. So what I need to do is still find the value of the slope, which means that I will evaluate the derivative at the point -1, 1. So anywhere there's an x, I'll plug in -1. And anywhere there's a y, I will plug in 1. And then I'm simply following my order of operations to find my value. So -1 cubed is -1 times 8 is -8. 1 squared is 1 times 5 is 5, so I'll be subtracting 5 on the top. In the denominator, 1 squared is 1 times 21 is 21. And then 10, I forgot my 1 there, times negative 1 times 1 will end up making that a minus 10. And then simplifying, I'll have negative 13 on top and 11 on the bottom. So this is the slope of my equation. So finally, to write the equation of the line, utilizing point slope form right here, I'll do y minus the y value, which is 1, is equal to the slope, negative 13/11, times x minus the x value, and subtracting negative 1 is the same as adding positive 1. And I can leave it in this form, or if you choose, you are welcome to change it into slope-intercept form.